Thank you very much. It's a great honor to be here today. We're really about to announce a huge breakthrough for humanity. We are about to take a picture of something that one man alone, dreamt, imagined 100 years ago in 1915, Albert Einstein. Imagine that. This idea that a very big weight transforms geometry, that when the mass is too heavy, you make a hole, a mysterious hole, where nothing can get out of it, where all is absorbed. Michael Kramer here from the ERC said the history of science will be divided into the time before the image and the time after the image. We believe deeply in the freedom of science. We believe that scientists are the ones to make the choices, that the choices of science are not done by politicians. We believe somehow in the intuition of science. Stephen Hawking once said something that I would like to finish these words today with you, with this excitement of us. He said, "It is said that facts are sometimes stranger than fiction, and nowhere this is more true than in the case of black holes. Black holes are stranger than anything dreamed up by science fiction writers, but they are firmly matters of science fact." And so this big moment is shared with so many in the public, so many today here, and I want to invite all the team. And for that, Professor Heino Falke is here. We will join him unveiling the image. So Professor, please come, and I'll go.
Still have to, thank you. We are looking into space, towards a galaxy, a giant galaxy, 500 billion light years away from us. Sorry, 500 billion kilometers away from us. Very big galaxy which was suspected to host a supermassive black hole in the very center. 101 years ago, someone discovered a streak of light, which is plasma shooting out of the center of the Milky Way, marking the supermassive black hole. I never believed that this black hole was as big as people said, until we saw that. This is the nucleus of the galaxy M87, and this is the first ever image of a black hole.
In April of 2017, all the dishes in the Event Horizon Telescope swiveled, turned, and stared at a galaxy 55 million light years away. It's called Messier 87 or M87. And there's a supermassive black hole at its core. And we are delighted to be able to report to you today that we have seen what we thought was unseeable. We have seen and taken a picture of a black hole. Here it is. This is a remarkable achievement. What you're seeing here is the last photon orbit. What you are seeing is evidence of an event horizon. By laying a ruler across this black hole, we now have visual evidence for a black hole. We now know that a black hole that weighs 6.5 billion times what our sun does exists in the center of M87. And this is the strongest evidence that we have to date for the existence of black holes. And it is also consistent, the shape of this shadow, to the precision of our measurements with Einstein's predictions. The bright patch in the south that you see tells us that material moving around the black hole is moving at light speeds, which is also consistent with our simulations and predictions. And this image forges a clear link now between supermassive black holes and the engines of bright galaxies. We now know clearly that black holes drive large-scale structure in the universe from their home in these galaxies. And we now have an entirely new way of studying general relativity and black holes that we never had before. And as with all great discoveries, this is just the beginning.